Hey everyone, welcome to this IBDP HLSL course, and let's move to our next topic, which is SL 3.2, in which we are going to talk about the trigonometry today. Means the use of sine rule, cosine rule, tangent, these trigonometric functions in a right angle triangle as well as in a non-right angle triangle. The sine rule is there, cosine rule is there, right? And we will see how to find the area of a triangle using trigonometric functions and if its side lengths are given and all. One more thing, in the SL part, this section does not include the ambiguous case of sine rule that we will learn in the HL part. Okay, so now let's start with a right angle triangle. So trigonometry is made up of tri, which means three, gon means the sides, and metry is the measurement. So basically we are learning about the three sides and their measurement and angles as well. Okay. So consider a right angle triangle ABC, where angle B is the 90-degree angle. Okay. Now in this one, consider an angle theta here at A. So corresponding to this theta, the side opposite to theta, this side BC is called opposite side, right? This is hypotenuse, the longest side of this right angle triangle, and the base part in this case here is the adjacent side, which is adjacent to the angle theta. So in this way, you can construct these opposite side, adjacent side, and hypotenuse sides. We can apply the Pythagoras theorem. You are already familiar with that. In a right angled triangle, like here, AC square will be AB squared plus BC squared. Okay. Now, trigonometric ratios. So you have to remember so ka toa, right? So ka toa. So stands for sine theta is given by opposite over hypotenuse. So as you already know the side lengths and their namings in this triangle ABC. That also depends on your angle of observation. This time I am taking angle A as the angle of observation. This is the angle we are talking about. But if this is angle, we are talking about the angle C, let's say this one is, let's say, alpha angle. So for this alpha angle, AB is going to be the opposite. Okay, remember this. For alpha angle. For theta angle, AB is adjacent. Okay. Now, after this, so ka toa, so means sine theta is given by opposite over hypotenuse. Ka means cosine theta is given by adjacent over hypotenuse. And toa is tangent theta is given by opposite upon adjacent. And their reciprocal functions are, for sine theta is also 1 over cosecant theta, cosine theta is also 1 over secant theta, and tangent theta is also 1 over cotangent theta. Okay. And three trigonometric identities that you need to remember. Sine squared theta plus cosine squared theta is equal to 1. 1 plus tangent squared theta is equal to secant squared theta. And 1 plus cot squared theta is equal to cosecant squared theta. These trigonometric identities are also important. You can anytime construct these using the Pythagoras theorem. That's it. Okay. So let's see how can we use these trigonometric ratios, right, to find the angle or sometimes a missing side as well. So in this case, we have to find the value of angle theta in this right angled triangle whose hypotenuse is 4.9 and this side, what side is this? So we are talking about this angle theta. So corresponding to this side is opposite and this is hypotenuse. So we need to look for that relation which gives us opposite and hypotenuse relation. So yes, so I can use sine theta equals opposite 1.8 over hypotenuse which is 4.9. So from here we can find the theta which is given by arc sine of 1.8 over 4.9. Okay, now you can easily find the value of this angle using your GDC. So when I enter these values in the GDC, I'm getting theta equals 21.55 degrees. Okay, in the degrees, that's the value. Now let's talk about the trigonometric ratios in a non right angled triangle. Okay, so consider a triangle ABC. Let me tell you the nomenclature. The side opposite to angle A, this is angle A, and the side opposite to angle A, which is BC side, is represented by small a. Side opposite to angle B, which is AC side length, is represented by small b. Side opposite to this angle C is represented by the letter small c. Okay. It's not a right angle triangle in this case, but still we can use sine rule, cosine rule. Okay, let me tell you about those. So this side length is A, B and C respectively. Now, after this, after this, let's drop a perpendicular from this vertex A to the BC side length, and let's give it a name D. Okay, D. H is the height of this AD perpendicular. Okay, let's call it H. Now let's talk about the sine rule first. How to apply it, how to create it. For the sine rule, consider these two triangles. First one is this triangle and second one is this triangle. Both are right angle triangles. Yes. So in the triangle ABD, we can use sine of B. This is angle B. So sine is opposite upon hypotenuse, gives me H over C. And similarly, in the triangle, this one, let's apply the sine C value. So sine C will be H over B. Okay. So that gives me these two. Now H is common in both of these. So equate the value of H. So from here H is C sine B and from here H is B sine C. Equate these two, we will get this relation C sine B is equal to B sine C. Now just use the cross multiplication. Take this C to this side and B to this side, right? So we will get sine B over B equals to sine C over C. But this time we only used a perpendicular from A to BC. Okay, but if I drop a perpendicular from B to the side AC in the same way, let's call that height as say L. Okay, so corresponding to this L, again it is perpendicular, I will get the sine theta value, sine C value, right? And when you calculate this, yes, you can get a relation in sine A and sine C, which is coming out to be, which will give you sine C over C will be sine A over A if you drop a perpendicular from B to this side. Okay. Hence, we can say sine A over A equal to sine B over B is equal to sine C over C. That's your sine rule. We generally use this sine rule if two angles are given to you and one side is given to you. You can use this to find the third side. Okay. Now, next rule is cosine rule. Cosine rule means cosine theta we have to apply. So consider this BD side length as x and the CD side length as, what will be that? A minus x, because this total is A. Okay. So in this way we have x and A minus x as our side lengths. Now again consider the same two triangles, this one ABD and ADC, and apply the cosine theta. Let's apply it here first. Okay. So if I apply the cosine theta, can I say I will have cosine B is equal to x over C, adjacent over hypotenuse. Adjacent over hypotenuse. But it's okay. C is okay. But what about x? We don't have the value of x. So we need to find the value of x in terms of small a, small b, and small c. Okay. For that, apply the Pythagoras theorem in these two triangles, this one and this one. So we will get c squared is equal to x squared plus h squared from this triangle, and from here we will get b squared is equal to a minus x whole squared plus h squared, or you can write it a minus x minus a, its whole squared, so that will not affect your answer. Now from these two relations, equate h squared. Okay, find the h square value from here and here, just equate them. You will get another relation, c squared minus x squared is equal to b squared minus x minus a whole squared. Now use this relation and solve for x. Okay. Solve for x. You will end up getting some value of x, plug in that value of x here. Okay. So from here we will get x as c squared plus a squared minus b squared over 2a. Now plug in that value of x back to our relation, right? And hence we will get cosine b equals a squared plus c squared minus b squared over 2ac, in which we have only a, b, c, no x, no h, right? So that's the value of cosine b. Now, similarly, you can find the values of cosine a and cosine b, right? By dropping other perpendiculars. For example, if you drop a perpendicular from b to this side, so this time you can calculate the value of cosine a or the cosine c. Okay. So once you do this, you will get cosine is equal to b squared plus c squared minus a squared over 2bc, and for the cosine c as well. Basically, the theme is if you are looking for angle A, so cosine of angle A is given by taking the sum of squares of adjacent sides, means c squared plus b squared. So cosine A is equal to c squared plus b squared minus opposite side a squared divided by 2 times the product of adjacent sides. Similarly, you can apply it for cosine B and cosine C also. It's a way to memorize this result only. Okay. Now the third and the most important part, area of triangle ABC. Okay. So we already know if we have a triangle, then its area is given by half into base into height. So area of triangle ABC is also half into base into height. We have half base, let's say a. So base is already known to us, a. The thing is, height, h is the height, but we need to find this value of h in terms of angles or the side lengths, not h, right? We're not going to calculate h value every time. So for this h value, this time you can either use this triangle abd or triangle acd, like this, or you can take any other height also. Accordingly, you have to change the base. So that you can find from here, right? The value of h is either c sine b or b sine c. You can use either of these values, you will get same result. Okay. So if you use this one, okay, so from here I can say h is equal to c sine b. Plug in that h here and we will get area of triangle as half a c sine b, or I can say half ac sine b, which is half, if you have a triangle, so this side is a, right, this side is c, and this is angle b. So you only need two side lengths, adjacent side length, and the angle between them in order to calculate the area of the triangle. Okay. Similarly, you can apply the same thing for C also. If you use height as B sine C, you will end up getting another result, but gives you the same answer, right? So half AC sine B, or half AB sine C, or half BC sine A. You just need two adjacent sides multiplied by sine of the angle between them, whole divided by 2, gives you the area of the triangle. Okay, let's apply these. Here is the question. It says in this following diagram of the quadrilateral ABCD, all the side lengths AB is given as 11, BC side length is given as 6, angle ABD is 100, ADB is 100, CBD is 82, and angle A is also given as 59. Okay, now let's find the value of dB. So approach is important. What can you do to calculate the value of dB? dB, you can pause the video and try it by yourself also. Okay, this is dB. So you can find the dB here using this triangle, right? This triangle ABD, because here this angle and this angle, two angles are known, one side length is known. You are looking for this side length, missing side length. As I said in the sine rule, you can use it if you have two angles and one side length and one other side lengths are missing. You can use it. Okay. Now I will use sine rule here. So I have dB over sine of 59, right? This angle. Similarly, 11 over this sine of 100. Yes, from here we can calculate the value of dB. dB comes out as 11 over sine 100 times sine 59 degree. Using GDC, we can get the answer as 9.57, correct up to 3 significant figures. Now, the line, this is find the length DC. So this time, yes, we have this dB length, which is, let me write here, 9.57. So we are looking for DC, this side length. So yes, you can use the cosine rule this time because these two adjacent side lengths are given and the angle between them is given. So you can use these to and apply the cosine rule, right? So let me write it for you. Cosine of 82 is given by sum of squares of adjacent sides. So 9.57 squared plus 6 squared minus the required side, which is DC squared, whole divided by 2 times 9.57 times 6. Yes, simplifying this, we can get the value of DC also. Okay. So now let's apply it and get the value of DC accordingly. So DC comes out as square root of 111.677, or you can say 10.6 centimeters. Now we have side length. Now the third part is, this is find the area of the triangle DBC. DBC, we have this all the side lengths and we have one angle. So what we can do? We can simply use the formula that half of product of these adjacent sides, which is 9.57 times 6 times sine of the angle between them, sine of angle B in this case. So from here, yes, we can get the value of area of the triangle. That's how we can apply these trigonometric ratios or rules. Okay, so now you know about the how to find the angles and the side lengths in a right angle triangle, and the Pythagoras theorem is also important here. Okay, second one, when triangle is non right angle triangle, so using the sine rule, cosine rule, and the area of triangle. Okay, so here's a homework question for you. You can take a screenshot and try this question all by yourself, and I'll see you all in the next session. Okay, so till then, keep watching, keep learning. Bye bye.